Hello, hello, hello. Good evening, Central African time. Good afternoon if you're watching us from the United States of America. My name is Freddie Mashate, and I am your host this evening. Let me start by just welcoming you, everyone, to SciFest Africa Online. Of course, it is the first time in 24 years that we are hosting an online delivery of the festival. For some of us that are here at SciFest Africa, it has been an amazingly great time to learn, and really we are inspired and thankful for the opportunity. The festival theme for this year is Take Root Nurture, and it is inspired by the UNESCO declaration that 2020 will be a year of celebrating plant health. We of course recognize that plants form an essential part of all life. As we close off October, where we were celebrating space and astronomy in a collaboration with the SAAO, and as we enter into the month of November, where we'll be looking at climate change, I think today's topic is really best situated because it allows us to, as we are coming out of space, to look at planet Earth from space and see what is going wrong. The topic for tonight's session is space as an aid to a sustainable planet. It is inspired by the fact that South Africa, with many other countries, are affected by climate change and other specific local environmental disasters. A need arises to expand our human capacity and wealth to analyze and develop solutions for addressing these challenges in a sustainable way. This presentation will highlight the importance of monitoring the Earth's land and water from space, air, land, and water in a connected way. In addition, this presentation will provide a strong motivation for observation from space and show how communities can become an integral participant through the design, build, and launch of their own satellites and/or the use of data from satellites. To help us, go through this presentation, we have two very special people. The first is Professor William Edmonson from North Carolina Agricultural and Technology State University in the United States of America. He is presently the director of Small Satellite System Research Center at the university, whose department whose research focuses on advancing the capabilities, functionality, and scope of mission for small satellites, particularly in the area of inter-satellites communication and verifiable model-based system engineering. It is a mouthful. I do believe that he'll be going through some of this during his presentation. He is also collaborating with universities in Ethiopia, Portugal, South Africa, Spain, and Nigeria on human capacity development, along with research on small satellites and autonomous vehicle development. An interesting fact about Professor Edmonson is that he is a collector of African science fiction. To help him with the presentation, we have Miss Deirdre Courtney. She is a PhD candidate focusing on climate change displacement at Western Michigan University. At the university, she teaches courses on climate change and marginalized populations. She founded School for Climate Action Michigan and serves on the City of Portage Environmental Board. Ms. Courtney is also a member of the Institute of Public Scholars, National Black Climate Action, and sorry, I'll take that again. I think it's called the National Black Climate Action Network and Citizen Climate Lobby. Ladies and gentlemen, as they are going to be going through the presentation, if you are on the Zoom platform, please interact with us, ask questions and comment beforehand, because a time will come where we'll open up the floor to discussions, and some of those questions will be what we will be addressing. If you are, of course, on Facebook, use the comment section because we'll also be monitoring those. To Ms. Courtney and Professor Edmonson, thank you so very much for honoring our invitation. And I think from here, the floor is all yours. I will be joining you after the presentation. Thank you very much.
Yes, thank you, Freddie, for the introduction. And As Freddie mentioned, we'll be sort of merging the concepts of space and sustainability, but hopefully everybody can see my screen now. But we're going to begin by taking you on a journey. And this is going to be a journey from Earth to the cosmos and back. And so in this journey, I actually hope to demonstrate how connected we are, not only to each other as people, but also to our environment and to space, particularly as the space economy grows. But I also want to show that we cannot solve the issues of Earth sustainability by ourselves, where it would take a concerted effort by all through respectful communications, collaborations, and do this in an environment of peaceful coexistence.
Prof,
Yes?
apologies for interrupting. We cannot see your screen as yet.
Really? Oh. It would help if I shared the screen.
Perfect, perfect. We can see it now.
So the introductory slides, I apologize for not hitting the share screen button. But as I mentioned before, that in terms of this presentation, we're going to, again, take you on a journey. And I believe I mentioned that the journey is going to be from Earth to the cosmos and back. But the point I want to make really is that we're going to show how connected we are. And not only on land, but in space. The Earth and its inhabitants are more connected today than at any other time in history. And that connection is actually becoming more and more ubiquitous. And so as we become more connected, it becomes extremely important that we understand the effects that we all have on not only climate change, but to ensure that the Earth remains inhabitable for all of us. For if we do not turn this thing around, we don't turn the climate change and get back to being able to grow in a sustainable way, then the Earth will exist, but we might not. So it would be us, the humans, who become extinct. For the planet will live on as it has always done in past epochs. You know, we had dinosaurs and a big meteor hit, and the Earth went through a reset. So it could happen again, and evolution will occur from its beginning. But to start this journey, I want to pass it on to my colleague, Ms. Courtney, and she will start this journey on the planet Earth.
Thank you, Prof, and thank you, Prof, and also thank you to everyone for having me today. I want to start off by describing sustainability. So sustainability is described as the study of how natural systems function, remain diverse, and produce everything it needs for the ecology to remain in balance. Essentially, Earth as a whole is a closed system. So all activities must live in balance. And according to the author of the book Collapse, How Complex Societies Choose to Fail or Survive, there are countless examples throughout human history where civilizations have damaged its own environment and seriously affected its own survival chances. Sustainability takes into account how we live in harmony with the natural world around us, protecting it from damage and destruction. We ultimately need healthy communities, clean air, natural resources, and an atmosphere free of toxins. We must live within our means. Everyone should have access to a fair share of food, water, shelter, and healthcare. Sustainability aims to use its resources efficiently. So, what is the relationship to what is the relationship of climate change to sustainability? It's an important one. We know that climate change is already impacting public health, food, water quality, migration, peace, and security. Left unchecked, all of the current and future gains will be rolled back or compromised. Our investments in sustainable development will only help to address issues with climate change by building resilience and reducing emissions. In fact, climate change will be a major driver of sustainable development. Tackling climate change and fostering sustainable development are two mutually reinforcing sides of the same coin. Sustainable development cannot be achieved without climate action. The United Nations Sustainability Development Goals will help us to address these issues. Sustainable development has been defined as development that meets the needs of the present without compromising the ability for future generations to meet their own needs. The UN has established 17 sustainability development goals established by 193 countries around the globe. These sustainability development goals, or global goals as they're sometimes called, are a collection of interlinked objectives designed to serve as a blueprint to achieving better, more inclusive and sustainable future and a sustainable future for all. Eradicating poverty in all of its forms is an essential requirement for sustainable development, which requires inclusive and equitable economic growth, creating greater opportunities for all people, reducing inequalities, fostering equitable development and inclusion, all the while promoting sustainable management of our natural resources and ecosystems. It requires an integrated approach that takes into account environmental, economic, and technological considerations. For this to be achieved, it is crucial to harmonize some core elements are represented that are as represented by the three-tiered thematic pyramid we see here. World leaders adopted a new 2030 agenda for sustainable development, which is a plan of action for people, the planet, and prosperity, designed to shift the world onto a sustainable and resilient path. For sustainable development to be achieved, it is crucial to harmonize the three core elements of economic growth, social inclusion, and environmental protection. These elements are interconnected, and all are crucial for the well-being of individuals and societies. It is not uncommon, however, for any one of the targets to show up under multiple tiers. So let's explore a few of the indicators or targets that are important as it relates to climate change and sustainability. Here we have Sustainability Development Goal number 13. It is about climate action and the importance and urgency to fight climate change and all of its effects. Globally, it is important to establish national strategies and policies despite countries like here in the US backing out of the Paris Accord, the only real international policy of protection directly addressing climate change. Sustainability Goal, Development Goal number 13 seeks to promote awareness in education, institutional, human capacity to mitigation and adaptation, and ultimately seeking preemptive action versus reactionary or reactive action. Sustainability goal, development goal number 14 has a focus on water quality, reducing ocean acidification, overfishing, and exploitation, and taking action to increase economic benefits, especially as it relates to small islands and developing states that suffer the most due to these crises. And Sustainability Development Goal 15 promotes the idea that all life on land is essential and important for our well-being and economic future. We need to reduce deforestation, increase strategies to sustain forest and other critical biodiversity that not only serve as sinks for carbon capture and sequestration, but also critical land management is key in securing a future for all well-managed, conserved, and preserved lands. Sustainability Development Goal 15 takes into account disasters such as floods, droughts, and hurricanes, which by far are the most deadliest and costliest natural disasters all around the globe. And so here I'll turn it back over to you, Prof.
So in order to, or the impetus for getting all this done, for meeting these sustainability development goals, we need to understand that there needs to be a partnership. There needs to be this connectedness, not only between all of us as humans, but also our connectedness with the environment, with nature, with animals, but also with our activities in space. And one reason why space is very important in this is that by viewing the Earth from space, you begin to see there are no boundaries. You can't see where Zimbabwe, the boundary between Zimbabwe and South Africa, it's just a landmass. In conjunction, the other thing to show how connected we are is that all humanity evolved from a single source. From a space perspective, we all come from space dust, which form the galaxies, which then form the solar systems and the planets and asteroids and sun. And so this space dust created a life in both cosmos and on Earth. But also we can trace our ancestry back to a single woman in Africa. And so to say we're not connected is to me, is not true. And so we've been on Earth, so let's jump into space. And we're going far or deep into space. And so here we're looking at our galaxy, the Milky Way, and you see it operates in a spiral. And this circle is actually Earth's solar system. And so this is another way one can see connection. And note that we've already launched 2 satellites that have gone beyond our solar system, and it's still operational. So somebody somewhere, light years away, will see one of our technologies. Now, let's come closer back to Earth and just look at our Earth solar system, which is made up of our sun, 8 planets or 9 planets, depending on whether or not you view Pluto as a planet or just as a body. But we affect and we are affected by how we interact within this cosmos, both locally, when I talk about on the planet or your community, globally, the earth, and cosmically as we interact with our other planets, not only in our solar system, but also beyond. And why is it important? And understand that connection between what's outside of Earth is that we're very, very much affected by our sun. It creates life for us here on Earth, but it also can create havoc through solar storms. And solar storms are actually can become a big issue because it can knock out our communication systems. It can definitely knock out our distributed power systems. And as we go into space and become, and I won't say civilized, but as we make our communities on the other planets and our moon, the radiation by the sun could actually affect us to the point where it could create loss of life if we don't pretty much protect ourselves from it. The other thing which people have projected that we're moving to space from an economic standpoint. So we talk about the space economy, and we want to be able to do things like mine asteroids, living off planet, setting up cities on the moon and Mars. Definitely, most of our communications now is handled through satellites in space, and actually, and also Earth observation. And in fact, particularly with observing the Earth, over 50% of the global climate indicators can only be viewed from space. In that respect, space has become as a critical infrastructure. And what I mean by critical infrastructure is that it is essential for the maintenance of vital societal functions, health, safety, security, economic and social well-being, and the disruption or destruction of any of these infrastructures can significantly impact a member state. And so what is space as defined as critical infrastructure? And its services become essential. And one example of that is just the GPS. A lot of times we can't even get around without our cell phones, which are connected to the GPS system. So it's essential to the smooth running of our societies and economies, and to our citizens' security depends on it. And so what we see here is a list of what many nations, and this chart actually comes from the Council of European Union, of what are the typical nation's critical infrastructure. And you can see many of these actually have a space component. Communications, defense, finance, through the GPS and communication satellites, transportation. And so we'll see in a later slide that even under government, they use a lot of their satellites to monitor things like land management. And so in terms of monitoring the planet's health, and I mentioned these global climate indicators, particularly from a global climate observation system, and this is, again, from the several Earth monitoring satellite systems that exist. We can actually measure temperature and energy, particularly surface temperature and ocean heat, atmospheric composition. So we can look at pollution in terms of atmospheric CO2 and even nitrous oxide, ocean and water around ocean acidification and sea level, and also the cryosphere, looking at glaciers. And this becomes a big issue, again, with South Africa with bases in the Antarctic. You know, as we go through global warming, what is the sea ice extent? And so what you see here in the corner is a Landsat image, and Landsat is a satellite that basically takes pictures of the Earth. And so this is a picture of the Hada Dam, a reservoir in the Fish River in Namibia. And so this, if there's the dam breaks, we can actually see and track the flooding. Furthermore, in concentrating on space critical infrastructure, and just in general, we have satellite systems, as I mentioned before, communications, both military and civilian, Earth observation, weather and climate monitoring. And as you see here in the corner, we actually have a picture of a small sat called RainQ, and its function is to observe the evolution of the weather. We have oceanographic, where there's another CubeSat or small sat Seahawk that tracks ocean color. So we can look at things like hazardous algae blooms. But the other thing we can do is space situational awareness, tracking and surveillance of other satellites, space weather monitoring. If there's a storm, we want to know if it's going to hit, but also near Earth orbit detection. And here, if there's an asteroid that we want to be able to track asteroids that might hit Earth, because that can do, as we've known before, extreme damage. The other part of this, and the reason why it's critical infrastructure, particularly from a economic development standpoint, we can use these space assets to do on-orbit repair, on-orbit manufacturing, development of some pharmaceuticals, but also, as was recently shown with the Asari Rex mission, is the precursor to mining asteroids. We want to be able to manufacturing because it's cheaper to manufacturing in situ than manufacturing everything here on Earth and then taking it to wherever it needs to be outside of either on the moon or the Mars. But also we can do planetary weather monitoring. But what is its specific utility here on Earth? And so in terms of resource management, we can look at things like deforestation, evaporation of lakes, air quality, which is a big issue, crop yield and quality. But this also gets into things like smart farming, ocean temperature, which directly gives us knowledge of where to fish and what fish might be going extinct because they can't handle the extreme temperatures. But also in terms of the government, land and water management and urban planning. This way, through space, you can monitor and deal with land disputes. And I know that there are several countries, Nigeria and Ethiopia, that are actually thinking about launching satellites to just handle land disputes. But also it could be used for disaster monitoring. In the US, we use it significantly for monitoring of floods, particularly forest fires, mudslides, etc. So what is a satellite? One can actually think of a satellite as an autonomous vehicle, but this is an autonomous vehicle that resides in space. My focus and what is probably or an economical entry into space, particularly for spacefaring nations or new spacefaring nations and communities, is small sats. And NASA actually classifies small sats as being anything less than 180 kilograms. And so what I've demonstrated here in the blue blocks, the different classes of small satellites. You have pico, which are very small, roughly around 10 centimeters and 1 kilogram, going up to nano class of satellites, which is 10 kilograms, roughly around 30 centimeters on the side. And furthermore, and continuing to micro and mini. One class or subclass of small sats that has really started in the university setting are what are called CubeSats. And CubeSats is really just a small sat form factor that is made up of 10 by 10 by 10 centimeter cubes that what you can grow to bigger cubes, like a 2U or a 3U, which happens to be 10 by 10 by 30. And just to give you an idea of how small it is, this is a 1U CubeSat, and you can see it fits in the palm of one's hand. So why are small sats important? Due to its being constrained by size, weight, and power, in effect, what it does is reduces the cost of development, but also reduces the cost in launch. And this is why a lot of universities and actually high schools have been able to design, build, and launch their own CubeSats in space. So there's definitely a lower point of entry. It enables multi-satellite missions. So to get around the complexity, do it through simplification. But also we don't have to develop this for 40-year or 20-year or 10-year mission. A lot of these only will last anywhere from 3 weeks to 3 years. And so you don't have to design it with a lot of redundancy. But here's the important thing is that you can manage this with flat funding. So give me, a couple of $100,000 or a couple of $1,000 every year, and I can continue with this program. But another important thing, which we've been using it, is to promote STEM or STEAM education. And so to get into the smaller satellite world, it does require STEAM. And here, when I talk about STEAM, I'm talking about science, technology, engineering, math, and where the A stands for the arts. So just because you're not a science or technologist does not mean that you cannot take part in this development. We can bring together a distributed system of small satellites to handle more complex missions. And this is being done around ocean science, space weather, planetary exploration, but it also can be used to complement larger space systems. But we can also integrate this with other various types of autonomous platforms. And this is where we can actually improve the performance of our observations. And so what I'm showing here pictorially is that you have your space assets, you have your UAVs, your air drones, you have your land communication systems, but also to connect it with underwater. And so by bringing all this together and understanding that and designing the system or system of systems to work together, then you can bring about a symbiotic behavior of all. And you can get better temporal, spatial, and spectral resolution. The other thing that this requires is to enable sustainability, as I alluded to before, is going to take this bigger picture. And I alluded to this when we talked about Sustainability Development Goal 17. And it's all about the communities coming together. And there's this term called convergence, which really means integrating knowledge, methods, expertise from all the different disciplines to solve a problem. And so it could be, we're going to need organization issues, both science and technology. It's going to require the societal and political means, the physical environment. You need to be able to make sure that you can work within your community, but also think as you work within your community, work in your environment, what effects does it have globally? But also both interpersonal and interpersonal. And these are considered the sustainability influencers. So this is just definitions. Due to time, I'm going to gloss over this. But one of the things that I at least want to focus on is that the social and political policies to facilitate this collaboration, and this is what the UN Sustainability Development Goals is all about, but also being able to share across diverse perspectives. So in setting up the organization. And so how do you get involved? And you can get involved through community science and technology. And we can actually define this community science and technology as an emerging concept, one that deals with various aspects of the community and societal development. And here we can think of that is that everyone needs to take part in this. Just because you're not a scientist or you're not an engineer or you're not a political scientist doesn't mean that you cannot get involved, because in effect, it does affect you. So we do encourage you to be a collaborator in this process, because a lot of times they find out that the community actually has a perspective that we as scientists don't have. And we're actually working on a project in Michigan to bring both the science and technologists and policymakers with the community for doing land remediation, to removal of toxic chemicals from the land such that we can reclaim it. Furthermore, just to show you that you can be involved as a community, and it does not take as much as you think. There actually have been several challenges involving high schools to build CubeSats that will be launched. And actually here's one, it's called the ThinSat program, which was actually launched in Virginia. These are my students. So if you can't get access to an actual rocket, you actually can get access and do a balloon launch. But you can also do monitoring of your land, Internet of Things. And this one in the corner is actually a climate or weather station for an extreme environment. And this is actually up in the mountains of Chile, high up in the mountains. So I want to leave you with these next two slides. Earth is actually considered a blue planet. Seeing it from space, we see all this water and we think we have infinite water. But in reality, we don't have as much water as you think. And so if you look at this big blue sphere, that is all of the water and volume as it relates to Earth. And the small sphere is actually all of the fresh water. So we don't do this right, we won't, and we don't have water to drink. Uh, this could actually lead to wars and or extinction. So I'd like to thank you for both myself and Ms. Courtney, my cohort in arms, and we're ready for questions and Q&A period.
Thank you. Thank you so very much, Prof. Edmonson, Miss Courtney. I think the presentation was, insightful. There's a lot to learn. Sometimes it might seem like it's a lot to take in all at once. Please do interact with us. If you're on Zoom, use the Q&A function to send your comments and questions. If you're watching us, of course, from Facebook, you can always use the comment section. We will be monitoring that, and we should be able to address some of the questions that you bring. To just start off with, the questions, I think I'm just going to start off where we started, because I think there's a lot of issues that are interesting that were highlighted, and I'm just wanting to pick up where Ms. Courtney mentioned that climate change driving sustainable development. If we can just speak a little bit about that, because we've always seen it as something that is bad, bad, bad. But if it's now actually causing us to wake up and have some economic activities that develop countries and continents, then it seems like something that is now turning into something positive. So my question is how and where is this happening? Has it already started? Is it something that we're still to look forward to? Yes.
Should I?
Yes, I was going to say, Miss
Okay.
Courtney, that was for you.
Yeah, thank you. So thanks, Freddie. I definitely would like to say that this is one of the main reasons that the Prof and I sort of came together around climate change work. So my work as a PhD student, I look at climate change refugees and displacement patterns. And one of the major issues for displacement is obviously increased temperatures, but also looking at areas where some areas similar to what the Prof mentioned today, those areas in the Arctic that are, where we're seeing, melting of the ice sheets and things like that. So a lot of our work with the Riverview project focuses on students and young adults getting involved and the community getting involved to sort of tackle issues of, exactly like you mentioned, Freddie, it does appear to be, it seems daunting that climate change is something that we cannot or will not solve, but with the use of renewable technology like the SAT systems, CubeSats that the Prof mentioned, we definitely can look into resolving some of these issues.
Yeah. Interesting. And I think in the same note, I think you spoke about, this difference between being reactive and proactive. I mean, there's a lot of debate around that. And, I think we as a people, we tend to want to deal with things that we see now. And not only as people and as individuals, look at governments, especially in Africa, if you have a food crisis and you're being told that maybe in 50 years time, we won't have a planet to live in, you tend to want to solve something that is happening actually now. How do we get to that place where governments and people as individuals we become proactive? I think maybe to just start off by saying what are some of the challenges that are inhibiting us from being proactive and this thing that seemingly is important and will affect us and generations to come.
That's a great question, and I have lots of ideas on what we can do to be better. A couple of things is number one, we here in the United States have opted out of the Paris Accord. That necessarily is not a great idea because, as I mentioned earlier, it's the only international policy or agreement that all countries can sort of, buy into and, try to seek a solution together. That's one thing. And then the other thing is that, like mentioned in the question, we're already seeing things happen in terms of natural disasters, flooding, drought. These are issues that have been around for decades. And we can really look to frontline communities, some of the solutions and actions that they have taken so far as looking at those in terms of solutions for what we can do today. So I think if two great ideas is one, enacting or working with other countries to enact an international policy around climate change action, and then looking at frontline communities and the solutions that they have already adopted and using towards, making further strides.
And if you don't
Yeah.
mind, can I add something to that?
Yes, go ahead, Prof.
So in terms of what can be done and what is being done, and actually there are a fair amount of African countries who are actually taking a proactive, particularly those that are on the border of the Sahara Desert. They've been over the last, I can't recall how many years, but they call it the Green Wall, in which they've been planting trees. And it's actually been very effective. And earlier this year, Ethiopia said, we're going to plant, they had a day, and they said, we're going to plant 1 million trees. And it's going to be a national holiday. And so there are things being done, and that's just one. And so really it's a policy, but also understand that there could actually be a lot of economic development. And there's several organizations, and I hate to promote an organization, but at least they put out position papers. But the organizations like the World Economic Forum have actually positioned papers that say this could be a X billion dollar or $1 trillion industry. So Norway has actually used their oil dollars to pretty much, I believe they're saying by 2030 to be carbon zero.
Yeah.
They're not accepting any more carbon based cars. So in other words, even though they've made their money off of oil, if you begin to look at the Middle Eastern countries, they're now saying that oil is pretty much dead. Please, probably shouldn't say this. Nobody invests in oil anymore. You said I could be controversial. Because it is now cheaper to get electricity from solar cells than from oil.
So the transitions are already happening.
Yes. So it's happening in a lot of the European countries. It's happening in a few of the African countries. And China has gone all in. They might say they're one of the bigger polluters, actually the US is, but they're at least saying, we're going to do this. It might take us 10, 15 years, but we are putting in policies such that we can become zero emissions, net zero emissions. And so now it's just a time for the African community and the African American community to come together and
Absolutely.
be part of this.
Yeah, yeah, definitely. I think as you begin to speak, you do see that there's a lot of good work that is being done, and it is encouraging. But also, we do note that a lot of work still needs to be done. Um, Prof, I think you mentioned something about also looking at space from an economic point of view, and I thought you were mentioning things like mining asteroids, and building cities in Mars. My
Mhm.
question is to say, does that not also make us a little bit complacent, especially for those people that have the money, because they will say, oh, well, if planet Earth doesn't work out, I'll get onto a flight, catch a flight to Mars.
Yeah, and in fact, a couple of our very, very, very rich people have actually said that.
Yeah.
So, but again, hopefully I showed that we're still connected. And what we don't want to happen, as you said, I'm a big science fiction fan, and I don't know if anybody has seen the Expanse. It's we don't want a war between the Earthers and the Martians, and the Martians are just us, So I think we got to do this right, because really, without Earth, there's some uniqueness about living on this planet that we're not going to get into terraforming Mars in our lifetime, in our kids' lifetime, in our grandkids' lifetime. I might be wrong on that one, but
Well, not fully developed at least. And I think
right.
a good point here to make is that at least the technology will start developing and utilizing a lot of the technology before anyone can sort of inhabit another planet for a long while. So,
And also understand that technologies that are developed for space actually have an analog and a need and a use for here on Earth.
yeah.
So it's not like one versus the other. If I develop something for space, or if I develop medicine to take care of radiation, to mitigate radiation effects, that could happen here. Because all these old nuclear plants, as one goes, I'm still going to need that medicine.
Mhm.
So to me, it's not an either or.
Yeah. Yeah. I think a question that would, come, and I think it's a popular one, is to say that I think what is the difference between, small satellites and very large satellites? Are there things that are particular to the small satellites that a big satellite cannot do? And the reason why I ask this question is to then add on and saying, as we launch many satellites, and we've seen many launches happening, are we not adding to junk in space? Are we not creating that junk status in space?
Yeah, with your fellow countrymen, well, not your fellow countrymen, but with fellow South African adding a whole lot to the space junk. Uh, yes, and there are policies as part of anybody's space policy. There needs to be put in, as part of that policy, how to deal with space assets that either go awry or have passed their usefulness. And so, yes, and so any new satellite, there's a UN policy that no satellite must last longer than 25 years, and I think there's a newer policy where you must have some mechanism to either move it way out in space or to bring it down into the atmosphere. And so there are there are policies in place that the world in new and old spacefaring nations should abide by.
Yeah.
Mhm.
Yeah.
Yeah.
I mean, as we are, trying to just round up, because I do see that time is leaving us. I think a question that then arises is to say, how does the access to space provide opportunities for communities such as, Makanda? And does everyone have access to space? I think that's the starting point. And if we do, then what are some of the opportunities that communities can start benefiting from?
Well, one, if you have a cell phone, you have access to space.
Mm,
Because this, most likely, this event, me being here, Ryan being here, and you being in Makanda, there's probably most likely a communication link between Earth and space to here. On a more personal level, since I've been to Makanda several times, it could be things like land management. It could be around, water, climate monitoring, smart farming. It'd be nice for a farmer to be able to get data directly. So yes, I need to plant today, or no, I can wait till next week. And so you can get actual data. The other thing is STEM education. How do we get the kids more involved in not only space, but just in STEM, or just being comfortable around STEM activities and get them excited about going into this area. And so you can use these space to do that, and the bottom line is that you don't want the people to stop dreaming. Little kids dream and then they become old kids and they quit dreaming because of reality. How do we maintain them dreaming? How do we maintain them having a playful mind? And just give them things, give them access. So, Deidre, did you want to add to that?
Yeah, I'd
Because
like
believe
to.
me, Makanda is probably not too much different than Portage,
Oh, okay.
except
Well,
they have a better university.
okay. Well, being that the case, that I think that was exactly my response, is that this opens up an awesome opportunity for PhD students like myself and other college or university students for research. And again, looking at places in the Arctic and exploring, that type of research. So I think that's a great opportunity for students, and also people who are community members that are connected with any type of research in their areas.
Yeah. Yeah. No, thank you very much. I think what I am personally learning is to say, there's a lot to gain from access to space. And I think the big thing is resource management, whether that's water, land, etc. I think as we just try and round up, maybe this is the last question. I was not going to let this go. Is the solar storm something that is more likely? I mean, I think NASA did warn us sometime in January. And what are some of the things that would happen if that would hit us?
One, you would lose all power because it could actually shut down the power grid. And that's happened several times. And you can just have everybody look up the Carrington event. And that shows you just how devastating it could be. A big issue, let's say, for any oil producing nation that delivers oil through pipelines, it could actually help degrade the pipeline, causing leaks, which is again, you need to be concerned about. It could actually mess up your communications and your GPS. So you might have to revert back to the old days where you had an actual map, a paper map, instead of your cell phone. And so you might have to go back to the, I should say, the old ways, the indigenous ways. So it's real. And actually, I've worked with colleagues on a mission to set up a solar storm warning system using small satellites that circle Venus. And if we don't get the radiation problem right, we can't go to Mars. We can't go to the moon. We can't civilize those. I don't want to use the word civilize. We can't build communities on the outer planets.
Great. I think this was really insightful. If you're going to be watching this a little bit later, please leave a comment and tell us what you think. And if you're going to be reposting it, use hashtag TechRootNature. National Science Festival, use hashtag SciFest Africa. And yeah, tag us, send us comments on what you think. As we close off, any last words? I think I'll just start with you, Ms. Courtney, and then I'll come to you, Prof, for your last words.
Well, just to end on a positive note, climate change is real, but there are many, many solutions that are already taking place. And I was happy to be here with you all, and happy, inspired thinking moving forward.
Thank you. Thank you.
Yes. Yeah, and thanks again, SciFest Africa, for inviting us. This is actually my third time. Wish I was there. There's a couple of good restaurants that I wanted to go to in Wakanda, but just actually also interacting with the people. It was actually good. And so thank you. And hopefully next year, we'll all be in Wakanda.
Thank you. Thank you very much. Thank you, Prof. Thank you, Ms. Courtney. I think what I take away is sustainability, meeting our present need without jeopardizing the chances of future generations, of them also meeting their own needs. And the other thing is to say climate change is real. And if we continue doing what we're doing and not changing the way that we act, the consequences might be dire. Thank you very much, Prof. And to also the university, North Carolina, it's Agricultural and Technology State University. Thank you to you, Ms. Courtney, for also affording us time and the knowledge that you have. It has been really pleasant to be with you guys. And I think this is the end of the session. If you can just allow me to say to those that are watching that in October, we are going to be, in November, sorry, we are going to be looking at climate change. We have a lot of exciting activities that are coming up. So please do look us up on social media, look us up on our website. The details will show on a slide that we just follow soon. We are hoping to interact with you, going forward. Thank you very much and good night.
Okay, thank you.